Hi, I'm Mrs. Silton, and today I'll be helping to teach your math lesson. You're going to need a notebook and something to write with.
And I'll be co-teaching with Miss Hilton today. All right, let's get on to the actual lesson. Okay, so today's lesson is going to be on equivalent expressions and equations. And yeah, let's go on to the next slide. So the objective for today, if you read this out loud to yourselves, you're going to say, I can use properties of operations of addition and subtraction to create equivalent expressions.
Some of the vocabulary we're going to use today are the words coefficient. Coefficient is the number before the variable. A variable is a symbol of a number that we don't know yet. Usually we use letters as the symbol. So you can see by coefficient there that 5 is the coefficient, x would be the variable. An expression is a number or a variable or a combination of numbers and variables and operation symbols. An equation is more than one expression connected by equal signs. And standard form is the expression written in its simplest form with all the variables in alphabetical order.
Okay, so let's start off with this expression. Notice that an expression doesn't have an equal sign. It's just a combination of numbers and variables like Miss Hilton said. So Miss Hilton, so if we were supposed to expand this out, what would our first step be?
Well, since multiplication is repeated addition, we could start with the 5x portion of the equation and write it out as individual x's. So you can see that 5 times there it says x plus x plus x plus x plus x plus 3x.
What would the next step be after we expanded the 5x out?
So next we would want to expand out the 3x portion. And in order to do that, we're going to add 3 more plus x's at the end of our equation.
And so now that we know how to expand the expressions, how would you simplify them? How would you simplify all of that?
So just like a regular addition problem, we would go ahead and add those all up together. And so we can see that we have 8 total x's. So we would write that as 8x.
So the expression 5x plus 3x is the same exact thing as 8x. Okay.
Yes.
Let's look at another expression. So separate this out in your notes. 5x minus 3x. You see that the difference between this expression and the last expression is just the operation sign, our operation symbol. We're subtracting instead of adding these terms. So how would we expand this out, Ms. Hilton?
So again, for the first step, we're going to write 5 x's, x plus x plus x plus x plus x, and then we'll write the rest of the equation, which is minus 3x.
And then how would we expand out the minus 3x?
So for this next part, instead of writing plus x 3 times, we're going to write minus x.
And how would you simplify this expression?
Now, as we simplify this expression, we'll see that we have 5 positive x's and 3 negative x's, which is going to leave us with 2x as our solution.
So I want you guys to pause this. And so you can take this down in your notes. And okay. So resume the recording when you're ready. So we know that a variable is it's a letter or other symbol that represents a value that we don't know. But let's say we are given what the variable is. So if we know that x equals 2, what does the expression 5x plus 3x equal? So what would we do to solve this expression if we know what x is, Ms. Hilton?
So we can substitute 2 in for where the x is in the equation. So we would end up with 8 times 2, which means the answer would be 16.
And if you'd wanted to do it the long way, you could also just do 5 times 2 plus 3 times 2, and you should still get 16. It's just that because we simplified this, or we wrote this in standard form, we don't need to do it the long way. We can just plug it into the most simplified version of it. So what about if we know, if x equals 2 again, how would this turn out in the expression 5x minus 3x? How would we go about this?
So again, we can substitute 2 in for the variable of x, and then we'll see that 2 times 2 equals 4. Or like you had said before, we can substitute it in anywhere we see the x. We could do it with the addition and subtraction, or the 5x minus 3x. You could put 5 times 2 is 10, minus 3 times 2, which is 6, which still gives you 4.
Okay. So right now, just pause the video so you can write this down in your notes, and then just resume the recording when you're ready.
Okay. On this slide, we're going to have you rewrite this expression.
When we rewrite this expression, we can either simplify or we can expand it out. So if you simplified it, you would see negative 3x minus 2x is negative 5x. But if you expanded it out, you would have either minus 1x minus 1x minus 1x minus 1x minus 1x. But you could have also written out like this. You could have done minus 1x plus minus 1x plus minus 1x plus minus 1x plus minus 1x. These two expressions right here are the same exact thing. Okay, so what would the expression in negative 3x minus 2x equal if we know that x equals negative 5?
So take a moment in your notebook and fill in negative 5 for your variable and see if you can come up with the answer.
So pause the video and resume when you're ready. So now that you plugged in negative 5 for the variable, you should have come out with the answer of 25. Okay, so here we see that the expression 3 times the quantity of 2x plus 4y times negative 5. Notice that we have two variables here instead of just the one that we dealt with in the last slide. So how would we go about doing this, Ms. Hilton? How would we expand this out?
So one way we can do this is we can expand it. And so we can show that there are 2x's. So we would write 2x plus 2x plus 2x 3 times. And then we would need 5 of the negative 4y. We're going to notice that the operation is going to change from positive to negative when we multiply, when we write this 4y. We need to continue the negative sign over here. So we have minus 4y, minus 4y, minus 4y, minus 4y, minus 4y. And it just, when we expand it out like that, we can see each of the steps. And then we can combine our like terms.
And this would be the standard form.
Then that takes us to the standard form, which is 6x minus 20y.
Okay.
Now there's that we can do this instead of just expanding out, which is the addition. We can use the multiplication. We can go ahead and multiply 3 times 2 for the x variable, and then we can multiply 4 times negative 5 to get the y variable, and we can see that we get to the same equation, 6x minus 20y. Okay, now in your notebooks, go ahead and write down the following equation, and you can pause the video, expand the expression completely and write it in standard form. So you should have 2 separate answers, one that will be the long expanded version and one that's the short and simplified standard answer. And you can resume the video when you're finished.
Okay, now that you've done the problem yourself, you should have gotten the completely expanded expression of x plus 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 x. So you should have gotten 10 plus x's. And then you should have gotten minus y 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 minus y, or just minus 10 y's. But if you were to simplify this or write this in standard form, which is so much better than writing this completely expanded expression, this expanded expression is the same thing as 10x minus 10y. But what if we know what x and y equal? So what would the expression 5 times 2x minus 2y equal if x equals 2 and y equals 4? So here we just want you to find the answer. We don't want you to expand it out. Just find the answer, pause the video here, and resume the recording when you're ready. And you should have gotten an answer of -20 once you plugged in 2 for x and 4 for y. You could have either used the original expression, or it would have been easier if you just used the simplified standard form to do this. But yeah. Okay, so now that we've gone over how to expand and simplify or rewrite an expression in standard form with integers, now we're going to go over with other types of rational numbers with decimals and fractions. So if we have the expression 2 times 2.5y minus 3 times 3y plus 2x plus negative 0.5x, how would we rewrite this? How would we start to simplify this, Ms. Hilton?
All right, so if we want to walk through the process of simplifying this expression, we can start by writing it out in an expanded form. So we can write 2 and 5/10 y plus 2 and 5/10 y minus 3y, and that's going to be 3 times because we see the multiple of 3 there. And then we have plus 2x, and we can go ahead and take this next part out of parentheses by making it say -5/10 x. So our next step will be, after we have it expanded, we'll go ahead and we'll put our positive numbers together. So 2 and 5/10 y plus 2 and 5/10 y will give us 5y. We can put all our negative y's together and get -9y. And then we can leave the plus 2x, and then we'll do -5/10 x. Next, we can combine our like terms. So we'll put our y variables together for it to make -4y. And then we'll put our x variables together and end up with 1 and 5/10 x. So that gives us our simplified or standard form of that equation.
Very cool. So just pause the video here so you can take down this notes, and then we'll go on to the next slide right after.
Now on this slide, we're going to rewrite another expression with rational numbers, but instead of decimals, this time we're going to go ahead and use fractions. So if you want to, you can go ahead and pause the video here and see if you can work through this one yourself, writing it in expanded form and then bringing it back to standard or more simplified form. And then resume the video when you're done.
Okay, so now that we've taken the time to do it ourselves, what would the first step to simplifying this expression would be to expand this out. So since we have 2 half y's, we just do half y plus half y. So you see we have that twice. And then we do minus 1/3 y. No, yeah. Minus 1/3 y because we have -3 1/3. So we do -1/3 3 times, or we just do minus 1/3 y minus 1/3 y minus 1/3 y. And then we just leave the 2x here. I mean, you could do x plus x, or you could just leave it as plus 2x. And then you would add the half x. And after that, you would combine the like terms that are, well, like terms with the same positive or negative sign. So half y plus half y is 1y, and minus 3y minus 1/3 y minus 1/3 y minus 1/3 y is -y. So you do so you do 1y minus y, and then you have plus 2x minus half x, and this could be brought down to be 1.5 x. So that would be the, not completely simplified just yet. Here you would combine like terms again. 1y minus 1y would be 0y. And then you bring down the 1.5x and you're just left with 1.5x. That's a simplified expression. So that's what you should have gotten when you're simplifying all of this. This is the same exact thing as this.
So in today's lesson, we learned that when we combine like terms, we are able to rewrite expressions in standard form.
Exactly. So write this expression down. So write an equivalent expression to 2x plus 3 plus 5x plus 6 by combining like terms. So just take the, pause the video to take the time to write an equivalent expression for this by combining the like terms, and then unpause to resume the video when you're ready and you have your answer. And okay, you should have gotten, so 2x plus 5x, you combine those two to get 7x, and then you have 3 and 6. 3 plus 6 is 9. So 7x plus 9 is the same thing as 2x plus 3 plus 5x plus 6.
Think of if you can write a different equivalent expression for the same expression, 2x plus 3 plus 5x plus 6. What are some other ways we can write that besides just the standard form of 7x plus 9? You can pause the video here and come up with a couple different ways. Some examples of things you might have come up with are 4x plus 3x plus 3 times 3. As you can see, your answer there would still get you to 7x plus 9. You can tell from the different colors where the variables match. So 6x plus x plus 2 plus 7 would work, or you could write it in completely expanded form with all the x's written out and all the 1's written out.
So thank you guys so much for sticking it out with us and being really good about doing the lesson alongside with us.
And we'll see you guys in the next video.
Yeah.